Okay, hello everyone. Thanks for inviting me, Elaine, and thanks, Gabriela, also for the great introduction, also for my talk, which will be centered around social media data. And in specific, I'm working on text classification models for tracking health trends in real time. So the first part of my talk will be centered around the common patterns I see when I work with other people on certain projects and they want to do sentiment analysis on their social media data. So this is a simplified, let's say very simplified version of the situation. So you have a research question related to health usually, but I mean, it could be really anything. And you think sentiment analysis can really help you answer it, or at least give you some insight on your question. And let's assume you want to understand what people think about vaccines online. Now, in fact, you could do sentiment analysis with 4 lines of code in Python. You can literally install this library called Vader, and you feed in some data you collected, and it will spit you out some labels, like some predictions. So the first one here would be like, great to see the ban of vaccines, and it will likely predict this as positive. And you're like, wait a second, this is actually an anti-vaccine post, right? So it should be really negative. And the same thing here for we need to stop the anti-vaccine groups online will likely be predicted as negative. And you want the opposite. And the reason why these are wrongly predicted are because the algorithm is picking up certain words like anti or great, and it will just spit you out a sentiment for that. So that's the first kind of conclusion that you probably end up at, is that what you likely are interested in is stance and not sentiment. But we will continue to call it sentiment analysis just to confuse everyone. So you end up with the conclusion that what you need is a supervised machine learning algorithm that can tell you in real time what is, in this insane amount of text that you collected. And so this is, again, a very simplified workflow, and it's also an ideal workflow. So you have data, you ideally have annotators, and they annotate your data. You can train a classifier, and let's just assume everything went great. You have a great algorithm, gives you 90% accuracy. You do your analysis and you write the paper, and you're done, right? It's great. You did it, and you publish. And the problem is only that 3 months later, after you've published your paper, it's very likely that that algorithm will not be as great anymore as it used to be when you trained it. And this is a phenomenon called concept drift. I'm sure most of you are familiar with this, but this is extremely problematic, especially when you do any kind of social media monitoring, because the discussion, say, around vaccines has already changed dramatically by the time 3 months afterwards. So your algorithm has never seen this type of data. Really, the only thing you can do to combat this is to collect new annotation data, retrain the model, and then somehow try to keep up with this concept drift, right? Now, the frequency of how often you would have to do this is probably highly dependent on your data. But let's say at least to a certain amount you will need retraining. So this will tell you that you need some form of continuous annotation, retraining, but you will also need a way to find out whether your model is actually performing worse over time. And so you're like, okay, going to start coding. And I'm sure many of you who have worked with Twitter data have experienced this, including myself for sure. So 3 months in, or 3 weeks in probably, your stream crashes. You suddenly notice that your retrained algorithm is worse than before. You end up with many different training sets and test sets, and you probably mess up on the way something, and you really need a vacation. And then, of course, when you're on vacation, it's happening. Everything crashes again, and so from that we can really see you need to avoid any kind of manual intervention. As soon as you think you have like one thing in there that you're doing, it's likely going to collapse at some point. And you need to monitor everything, even the monitoring itself. And of course, for that, you need some form of infrastructure. And so this is kind of where we came up with this idea of crowd breaks 2 years ago. And so this is a platform. You can go to that website, and the idea is that anyone, we ask the public to annotate the data, and we have set up the platform in a way that you supports multiple projects. Each project would have its own data stream, set of keywords it listens to, currently from Twitter, but it could be any kind of data stream that is public. And we then run the continuous crowdsourced annotation, and we retrain the models. We're using those interested AWS SageMaker, and then run visualizations of that data, of the trends back on the website. So the whole project is open source. It's under MIT. So it's also Dockerized. So really, if you want to set this up or check out the code, feel free to do that. So I want to quickly talk a bit about a few projects we are running on this platform. We have 2 public ones and a few private ones that are kind of in the going, let's say. One major project we've been working on for many years now is vaccine confidence tracking. And we actually do this in 6 different languages. So there will be 135 countries of their primary language. And so we're trying to really do this on a global scale. We have really good models for English language because we've been doing this for a while. Now the challenge is really to apply cross-lingual training to go to all these other languages and kind of get to a global scale of this. And with one sub-project in particular, we're working with PAHO on understanding these things in Brazil. Another project we've published on arXiv just a few weeks ago, or a month ago, I guess, is understanding the sentiment around CRISPR, or public opinion in this case. So CRISPR is a gene editing technology, and there has been a number of scandals surrounding this. So we were interested, can we see like certain patterns of how public opinion shifts potentially surrounding this technology? And for that, we have trained 3 different classifiers using BERT, one for relevance, so is this tweet relevant to CRISPR, then one on sentiment, and the last one on organism. And you can see things like, of course, strong spikes or negative spikes for certain events, especially the CRISPR babies event. But then also you can see patterns that, of course, people are most having most of their issues are with the human or the application to humans of this technology. And also we're working on this recent outbreak. I'm sure you've heard about this in recent news. So we've been starting to track on this, and it's really crazy. Here the major issue is that we have such a huge flow of information. We're collecting 10 million tweets per day right now. So it's quite something to process. But at the same time, of course, we want to be very quick at extracting certain signals from this data. And I think one type of information that is very interesting is, how do humans react to something like this, right? Are they like ridiculing it? Are they like completely, do they not care about this topic? So for example, the level of fear or worry is very interesting also from a disease epidemiology point of view. So there's definitely definitely lots of work to be happening here as well. So if you're also working on this, please let me know and we can talk afterwards. So again, just to wrap up, these are our 3 main things that are on our to-do list. So one is, as I said, the cross-lingual text classification. The other one is, as for some projects, it might make sense to run certain benchmarks so that we can compare these different algorithms. At some point, have some form of trust for these many different algorithms that we have for especially in the case of vaccine sentiment. I think it will make sense. And of course, we are trying to somehow provide insight back to the public as well with nice visualizations. So thanks for your attention, and if you're interested, so we're looking for postdocs and PhD, so get in touch with either me or Marcel after. Thanks. Yes.
I have a question. I'm not an expert on the concept brief, so I was wondering, you said that the only way to get around this is to completely re-annotate new samples. I guess concepts, they don't change in a day. Like, so
right.
You can try to find a place where both concepts are used and try to retrain model without huge manual annotation.
Yeah, so absolutely. In fact, I actually very much simplified that part. And I would actually say this is not entirely true anymore. For the last, I think, 2 years, I don't think this is completely true anymore. Because now, as you probably know, with algorithms like BERT, you actually need this fine-tuning step, right? And in a way, by just showing the algorithm recent data, so fine-tuning it a little bit from the recent data, it can somehow figure out from the existing conceptual embeddings what are the new ones, or like how do the new terms kind of fit in, right? But just by proximity. So you might actually need very little annotation data just to confirm that your algorithm hasn't really completely slipped out of, right? So you might need still annotation data, but more as a validation. And so I think that's also kind of cool for us, because obviously annotating these tweets is a very heavy work, and so yeah, it's cool developments for this project. Yeah.
Say one more question.
Yes.
Just a quick question. The vaccine confidence effort. Do you collect tweets only in English or also on the languages of the various countries?
Yes, exactly. So we have multiple streams for a different set of keywords for each language. So out of the 6 languages that we're tracking for currently, I think German, French, Italian, English, Portuguese. So and all of these have more or less. Well, we try to just translate it, but of course, in a way, the discussion might be very different in each country. So that's also something I haven't mentioned, right? So the discussion in Brazil around vaccines is very, very different from the US. And to a certain extent, we will need to tweak things.
You use geolocated tweets.
We try to infer the geolocation based on certain attributes, but most of the tweets are actually not geolocated, unfortunately.
Okay.
Yeah. Yes? Yes. All of the data, as far as our ethical review board is okay with it, we are trying to publish everything. So the problem is that the tweet objects, you cannot fully just share them. You can share, however, the reference to the object, right? So that someone wants to delete their content, they can still do that, and that the content will not be available anymore.